Chapter 9, continuing on, starting on page 222. On this page we have causes of soil and land degradation, and we have the definition of erosion and deposition. So again, when I talk about the causes, it's right here after the definition, soil degradation, and we have forest removal, cropland, agriculture, and overgrazing are causes of degradation. So degradation is a vocab word. So degradation means a decline in quality of a substance. It could be water, it could be soil, it could be air, it could be a habitat. So anything that is a decline in quality we call degradation. So erosion is when water or wind can remove soil from an area. Deposition is where does that soil go? And wherever it's deposited, we call that deposition. On this page, we have causes of erosion. And so make sure you know these three bulleted points: from over cultivating the fields through poor planning or excessive tilling, grazing with livestock more than the land can support before the grass can grow back, and then clearing forests and not replanting them or on steep slopes. So here are ways to minimize erosion. Right here we have this paragraph, and make sure you can write about on an FRQ several of these, like erecting physical barriers to capture the soil, planting vegetation because the roots of plants hold soil in place. No-till agriculture is another one. So make sure that you can identify several of these. All right, going on to the next page, but my pages are stuck, so let me try and undo them. There we go. All right, on page 224, we have the definition of desertification. It is not turning into a desert. It can be, but that's not the definition of it. So a loss of more than 10% of a soil's productivity can create what we call desertification. Doesn't mean that it'll be a desert, but we call it this. I know it's a confusing term, but that's just what it is. So how do we lose soil productivity? Through erosion, dust storms, and salinization are three main ways. So the Dust Bowl, we have this sequence of events that occurred. In the 1880s, the United States passed the Homestead Act, which allowed farmers to have 160 acres, and they had to farm it for a number of years, and then they got the land. And so in the 1900s, the 1910s, and the 1920s, farmers used up all of their acres of land, all 160, to grow wheat, because wheat is a cash crop. You make a lot of money from wheat, but wheat needs a lot of rain, and nobody knew this at the time, but those decades were extra rainy, more than normal. But farmers didn't know this because nobody had really lived there before. They didn't know that there wasn't that much rain in this region. We know this now because we have many decades of weather reports that we can look at, but at the time that the farmers started settling, nobody knew that it was just extra rainy, and that's not normal. In the 1930s, the rain stopped and a drought came in, and because the farmers had tilled up all of their soil, because that's just what you did back in the day. You tilled it up, you planted, you put your seeds in the ground, and then the rains never came, but the winds came instead and blew away all of that loose topsoil. And so that's the Dust Bowl. So a result of the Dust Bowl is the Soil Conservation Service. So the United States government put together an agency that helped farmers learn practices to keep their soil in place, so when there is a drought and there are winds, it won't blow away the topsoil. And you can see up here pictures of the Dust Bowl and the main areas of where it hit the most and where they lost all of that topsoil. On the bottom here on page 226, know what crop rotation is. We use crop rotation as a solution to a lot of problems, so make sure you really understand crop rotation. So make sure you read through this paragraph several times. So this section also describes for you different ways that we can prevent erosion, and there's lots of pictures here. So the descriptions are here and the pictures are here. And we have crop rotation, contour farming, terracing is on steep slopes, and then we have intercropping where you have different crops planted at different times or in different sections and strips. Shelter belts are a way to prevent wind erosion. You have these lines of trees in between your crops. You can see that actually around here on the Highway 126, the one you take to go to the beach to Ventura. Through Fillmore and Piru, you have big tall trees that are in lines between the fields, and that helps prevent wind erosion. And also they have a lot of citrus, and so it helps prevent cold winds from drying out or from freezing the oranges as well. Okay, page 228. Make sure that you can memorize 2 to 3 benefits of no-till erosion and be able to write about that on an FRQ if you're asked about it on an FRQ. On this page it talks about the importance of plants holding soil in place. So plants are very important to hold the soil in place. Let me fix my pages here. All right, turning a couple of pages to 232. Know the figure and caption about overgrazing and being a positive feedback loop. And on this page, know the different types of irrigation on 233. We have flood and furrow up here in California, which is a really big waste of water because all the stuff evaporates. We have center pivots where the sprinklers sit in the middle of a circle and they sprinkle all the way around. Conventional is just sprinklers like this, and then drip. So the best type for conserving water is drip. You just drip, 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 drip in the ground and it soaks in and doesn't evaporate. So drip irrigation is a solution to a lot of problems with agriculture as well. Okay, so let's talk about irrigation. So irrigation is basically sprinkler water, and it can evaporate over time and leave behind salts. Now it's just a tiny bit, so irrigated water has tiny, tiny bits of salt. It's the same as our tap water. You can't taste the salt, it's so small. But over time, that evaporation, I'm talking many years, it will build up and prevent seed germination or plant growth. And this process is called salinization. This is a really important term that the AP test asks about a lot. So how do we prevent this from happening? We prevent it through drip irrigation. So drop, drip, 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 drip at a time prevents evaporation. Sometimes we can plant crops that need less water, and so you don't have as much evaporated water if you don't need as much water. Water sensors, a lot of farmers put these computer sensors in the ground, and it only waters when the ground reaches a certain level of dryness, and then the sprinklers go on, so you don't overwater either. And then layers of humus on the soil prevent evaporation as well. Okay, so let's say you have salty soil, and what do you do now? You own this land, you want to farm, what do you do? How do you fix it? So mitigation means to fix. If you have a lot of fresh water to flush through the soil, you can do that, but in a drought or in some places where water is scarce, you don't really have the availability of fresh water to flush through the fields. You can also plant barley, which is salt tolerant, so there are still some crops that you can plant that have a certain tolerance for salty soil. So the next page talks about what are fertilizers. So you do need to know that these 3 substances make up fertilizer. Nitrogen for green leafy growth, phosphorus for roots, potassium for flowering. Really important. So we have different types of fertilizer. Inorganic means we're not talking about organic like organic foods. We're talking organic as in coming from a living thing. So inorganic means that it's man-made, or we call it synthetic in apes. And inorganic fertilizer is usually a liquid form or powder form that you put on your crops, and it's more likely to wash into waterways. And we learned in previous chapters that excess fertilizer, when it gets into waterways, can cause eutrophication. So organic fertilizer is made from living things, and one type is green manure, which is basically crop residue and vegetation that's allowed to decompose. Animal manure and compost are examples of organic fertilizer as well. On this picture here, it shows the problems with fertilizer runoff. We've already learned about eutrophication, but it can also soak into the ground and contaminate groundwater. So people that live on the farm and they use well water, which means they pump it up from here, can get contaminated water with nitrates and phosphates and things, which is not good. Oh, and then they cause air pollution with nitrous oxides that come from the nitrogen. It becomes airborne. It's actually a serious deal. In California, the air pollution from farming, from these nitrous oxides, affects the sequoias in the Sierra Nevada mountains in a negative way, the sequoia trees. Okay, so if it gets into groundwater and drinking water, you don't want phosphates because they can cause cancer, and you don't want nitrates because they cause blue baby disease. So what blue baby disease means is that because babies are so little, they're more susceptible to this. But if you have nitrates in your drinking water and you don't know it because you can't taste them, see them, smell them, the nitrates will bind to the hemoglobin instead of oxygen. So a baby will be breathing normally, but they'll be turning slightly blue because they're not getting oxygen in their bloodstream into their cells. Instead, the nitrates are fixing to those spots on the hemoglobin. It's a serious thing. All right, last sticky note for this chapter. Know what the Swamplands Act was, which was basically we drained wetlands to turn it into farms. But we have some consequences from that too. Know we've been trying to reverse some of that with the Wetlands Reserve Program. So this was an older act, and this is a newer one to try and fix the problems of the Swamplands Act. Farm Bill, know some of the issues surrounding the Farm Bill, and know the definition of Conservation Reserve Program, which basically, if you've got highly erodible land, the government pays you not to farm it and gives you money instead of farming it. And a lot of times that can be turned into natural area and habitat, as you read with the case study. That's the end of Sticky Notes for Chapter 9.